Hello, my name is Marco Gallegos. I am in Math 32, Section 40, and my topic is on uniform distribution. So, what is uniform distribution? Well, in statistics, this is a type of probability distribution in which all our outcomes are equally likely. Hence, let's take for example a deck of cards, which has uniform distribution because the likelihood of drawing any heart, club, or diamond or spade set is all equally likely, because all inside a deck of cards you'll have the same amount of cards for each type. Same thing with a coin toss. It also is considered uniform distribution because the probability of getting either heads or tails in a coin toss is the same. Uniform distribution can be visualized as a straight horizontal line. So for a coin flip returning a head or tail, both have the probability of 0.5 and could be depicted by a line from the y-axis at 0.5. There's two types of distributions: a discrete distribution and a continuous distribution. For discrete distribution, possible results of rolling a die provide an example of discrete uniform distribution, because it is possible to roll a 1, 2, 3, 4, 5, or 6, but it's not possible to roll a 2.3, 4.7, 5.5, 5.4, etc. You get the idea. Roll of a die generates a discrete distribution with probability 1 over 6 for each outcome. 1 over 6 being there is 6 faces on a die and you can only roll one side at a time, hence probability is 1 over 6 for each outcome. Some uniform distributions are actually considered continuous rather than discrete. A continuous distribution can be considered an idealized random number generator because this type of distribution has a continuous range from any range you give it. If you give it 0.0 to 1, well, you're not only dealing with 0.1, 0.2, 0.3, all the way to 1.0, you're dealing with 0.022, 0.122. You have infinite amounts of numbers when you have a continuous range. So in this picture below, it shows again probability of landing on each side, probability of hitting heads or tails. Well, that's discrete. Perfect random number generators, and probability of guessing exact times at any moment. Well, that's continuous uniform distribution. So for this mathematical explanation, well, a uniform distribution, sometimes known as a rectangular distribution, can be considered has a distribution of a constant probability. Hence, these graphs, each having a flat surface at one point, well, that shows its constant probability. And a quick tip is whenever you're doing uniform distribution at a continuous probability, these are events that are likely to occur. So when working out these problems that have uniform distribution, make sure that you know where data is inclusive or exclusive. This is just one example. On the left side, you have a discrete distribution of a roll of a die, and notice how all lines are equal, showing that you have a 1/6 probability. Um, and then for a continuous uniform distribution, well, there's more of a square. So for x function, for x variables, well, there's infinite amount of numbers between our range of -4 to 6, giving us the length of 10, and 1 over 10 will be our height. So our function is 1 over 10 from the range of -4 to 6, or 0 otherwise. This is how we write that. And now we move over to a real life example. Well, in this example, we have this data sheet given to us from a baby smiling in seconds of an 8-week-old baby. And if you look at the data, well, you can tell that there is no longer smiling time other than 23 seconds at a time. So we're using that in our probability density function. So we write it out as shown in the first line. F of x equals 1 over b of a. Then we solve for a new theoretical means and our new theoretical standard deviations, which will be 11.5 seconds for a mean and then 6.64 seconds for a new standard deviation. Lastly, these are some key takeaways. Uniform distributions are probability distributions with likely outcomes, and there's only two types of uniform distribution: discrete and continuous. And these are real world examples. So for example, height of the population is the example of normal distribution. There is income distribution in economy, and then we have shoe sizes, and shoe sizes, and that are all considered real world examples of uniform distribution. Thank you.